Here are the assumptions of the classical linear regression model. And one of the assumption is there is no specification bias or specification error, meaning that the model is correctly specified. Suppose a model is written as y equals to beta 1 plus beta 2 x plus beta 3 x squared plus beta 4 x to the power of 3 and plus the error term. But suppose for some reason the researcher decides to use this model whereby yi equals to alpha 1 plus alpha 2 xi plus alpha 3 xi squared plus ui, which is the error term. So if we compare this model with the previous model, there is a one term which is not written here, which is xi to the power of 3. So since the original model is the correct model, meaning the model that is used is omitting a relevant variable, which is xi to the power of 3. And therefore, the error term in this model, u to I, will be equals to u1i plus beta 4 xi to the power of 3. Meaning that the error term in the model used, which is u to I, will include the term which is not included, which is beta 4 xi to the power of 3 plus u1i. Suppose another researcher used the model yi equals to lambda 1 plus lambda 2 xi plus lambda 3 xi squared plus lambda 4 xi to the power of 3 plus lambda 5 xi to the power of 4 plus u3i. So here there is an extra term here, which is lambda 5 xi to the power of 4. So meaning that in this model, the researcher is including an unnecessary or irrelevant variables. So looking back at the original model, which is the correct model, yi as a function of 3 independent variables. So if a researcher did not write this term in the model, meaning that the researcher is committing a specification error whereby it is omitting a relevant variable. And if another researcher is adding a new variable, example beta 5 xi to the power of 4, which is not in the correct model, then the researcher also is committing a specification error whereby whereby he or she is including an irrelevant variable. Suppose another researcher is using model ln y as a function of all the independent variables. The right side is the same as the correct model, but the left side, which is a dependent variable, here is taking the log of yi instead of y. So meaning that this researcher also might committing a specification error where it falls under wrong functional form. So the correct model appears to be linear, but then this one is log linear. Consequences of model specification errors. So under this section, we will discuss two of the specification error, which is omitting relevant variable, or we say as underfitting a model, and also including unnecessary variables, which we say overfitting a model. So we will discuss the consequences of these two types, underfitting a model and also overfitting a model. So suppose this is a true model, yi as a function of x2 and x3, and for some reason the researcher follows this model y as a function of x2 and omitting the relevant variable x3. So what are the consequences of omitting the relevant variable x3? First consequences: if the omitted variable x3 is correlated with the included variable x2, or we say that the correlation coefficient between x2 and x3 is non-zero, the estimator alpha 1 hat and alpha 2 hat are biased as well as inconsistent. And also, if the correlation coefficient between x2 and x3 is 0, meaning that x2 and x3 is not correlated at all, between the included variable and also the excluded variable is not correlated, alpha 1 hat is still biased. So where the correlation coefficient between x2 and x3 is non-zero or is 0, still the estimator will be affected, meaning that the estimator is still biased. The third consequences is the disturbance variance sigma squared is incorrectly estimated. And due to this, the variance of alpha 2 hat, this is the formula, will be a biased estimator of the variance of the true estimator of beta 2 hat. And because of this, the consequences is that the usual confidence interval and hypothesis testing procedures are likely to give misleading conclusion. Now we look into the consequences of inclusion of an irrelevant variable or overfitting a model. So assume this is the correct model, but then we are using y as a function of x2 and x3. So we have an overfitting model whereby we are including an irrelevant variable. So what are the consequences? So what are the consequences when we have inclusion of irrelevant variable or overfitting a model? So the first one, the all as estimators of the parameters of the incorrect model, meaning alpha 1 hat and alpha 2 hat, are all unbiased and consistent. So this is, we can see the consequences is okay, and then the error variance sigma squared is correctly estimated, and the usual confidence interval and hypothesis testing procedures remain valid. So the consequences 1, 2, and 3 are actually the opposite of the consequences in the underfitting model. However, the fourth one is the estimated alphas will be generally inefficient. That is, their variances will be larger than those of the betas of the true model. So first consequences, second and third is okay. But then only the estimators, the alpha hats, they are inefficient.